All right, our last method is quadratic formula. This is one that I bet the majority of you know a little song to help you remember. Now, quadratic formula is derived by using completing the square. If we get a chance in class, I would love to solve this for you with completing the square because I think it solidifies how to complete the square in addition to showing you how cool it is that it's derived from that. But the quadratic formula is x, I need a pen, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, when I was doing that, how many of you just did pop goes a weasel in your head? Yeah, that's what I'm saying. Okay, there's many different ways. Pop goes a weasel is the most common, and it's x equals, oops, that's wrong. X equals negative b plus or minus square root b squared minus 4ac all over 2a. When I do nursery rhymes with my son, sometimes we do the quadratic formula. Just saying. It's cool that way. So here's our quadratic formula. Now, look at all these a's, b's, and c's. This is where it comes from. In standard form, you had ax squared plus bx plus c equals 0. So your a, your b, and your c are all the coefficients. So really, when you solve for x, you're just using numbers whenever you're coming up with that. The kicker to the quadratic formula, just like in the zero factor property, is the fact that you have to set it equal to 0 first. And you always want your lead coefficient to be positive. So you want your a value to be positive, and you have to set this equal to 0 so you actually get your a, your b, and your c that you're looking at. Okay, let's try some. Okay, our first example is, example 5, where we have x squared minus 4x is equal to a negative 2. Now remember, the first thing we have to do is set this equal to 0. So we really have an x squared minus 4x plus 2 equals 0. So until you get good at the formula, I would suggest writing it down on your paper. Sing a little song if you want to, whatever. As long as it gets down on your paper, that's the key. So fill in the blanks. You know, and your A in this instance is equal to a 1. Your B is a negative 4, and your C is a positive 2. So fill all of that in. So x is equal to the opposite of negative 4, which will end up being plus or minus the square root of your negative 4 squared minus 4 times your a of 1 times your c of 2 all over 2 times 1. Now the all over is the kicker. When people make a mistake on this problem, you're only putting the line underneath the radical. You need to put it underneath the whole thing. That 2 goes under all terms. So this is really, now notice all you have are numbers. That's what you guys want. Get rid of the variables and just work with the numbers. And here you go. You're welcome. So you have 4 plus or minus the square root of 16 minus 8 all over 2. So keep doing work. 4 plus or minus the square root of 8 over 2. You can break down that 8. So x is actually equal to 4 plus or minus 2 square roots of 2 all over 2. And just like any fraction out there, you have to make sure you reduce. There's a couple of ways to reduce this. You can have x is equal to, notice that there's a 2 in common with the numerator. Factor it out. And then the 2 on top and the 2 on bottom cancel. So you're just left with 2 plus or minus. Oop, I missed that. 2 plus or minus the square root of 2. So you have your two answers again, 2 plus root 2 and 2 minus root 2. So you have all of those options available. Or you can do the same thing where you take this 2 and split it up into each term and then just simplify. You'll end up with the same thing no matter what. Cool. Let's do one more. Okay, what if we have a 2x squared is equal to an x minus 4? So with this problem, notice the 2x squared is by itself on one side. However, when you're working these, you want to make sure that you keep your lead coefficient positive. So I'm going to go through here, subtract my x, and add my 4. Because I want it, when you set this equal to 0, you still want your lead coefficient to be positive. So you have a 2x squared minus x plus 4 equals 0. And now you get your A, your B, and your C. So your A in this instance is a 2, your B is a -1, and your C is that +4. And plug it in, plug it in. Now I have the opposite of B, or the negative of -1. I'm okay with you just writing a 1 there. Instead of doing negative of -1 like we did on the last problem, you can just write 1. Plus or minus the square root of this -1 squared minus 4 times your A of 2 times C of 4. Extend that all over 2 times A, which is a 2. Okay, let's do work. So x is now equal to 1 plus or minus the square root of 1 minus, what is that? 8 times 4 is 32, all over 4. Ooh, look what's happening underneath the radical. I end up with a -31. Anytime you have a negative under the square root, what do? That's right, pull out that I. So now I end up with x is equal to 1 plus or minus I square roots of 31 over 4. Now, you can break this up or you can leave it together. I think in some of these problems in this section, my math lab has multiple choice, so you can just leave it like that. But how many answers do we actually have here? We really have 1/4 plus the square root of 31 over 4i and 1/4 minus the square root of 31 over 4i. So if we were to put it in standard form with our complex numbers, you would get that. Otherwise, you can just leave it like that. The two most common ways to solve problems are the zero factor property, which is what we started with, and the quadratic formula, because those seem to be the easiest in working through the problems. Cool. Now we've got this one down. Let's sum this up and figure out what it is we've got going.